What does a high bay warehouse do in the sheet metal course? Quite simply, two interesting commands are explained, using the sheet metal parts. Contour flange, to create sheet metal profiles. And normal cutout, to create holes in the sheet with edges, perpendicular to the surface. And along the way, you will learn how to create a shelf, that can be customized with just a few clicks. Simply change the height of the support, and the number of shelves changes automatically. And with that, welcome to Sheet Metal, Exercise 4, with the focus, contour flange and normal cutout. Contour flange. Before we start the exercise, I would like to show you the possibilities of the command. The contour flange command creates a sheet metal profile, from an open sketch. If the sketch has corners, the bending radii are adopted, according to the default settings. Now it gets strange. The length of the profile is entered under width. It can go in one direction, or symmetrically, in both directions. Even if the direction of the sheet thickness is reversed, the bending radii remain unchanged. The Milter corners option can be used to adjust the angle of the ends. This quickly turns the profile into a frame. If the sketch also has radii, the radii of the sketch are adopted. If the direction of the sheet thickness is now reversed, the radii change accordingly. The sketch can also be created within the command. But it also works without a sketch. For example, the edges of a body can also be selected. And if I change the chamfer, the sheet metal part also changes. Only closed contour lines are not possible. These would then have to be created with the extrude command and the offset option. Now we start the exercise. Create the Z profile. First check the default settings. The Z profile should be bent from 5 mm thick sheet metal. The bending radius is also 5 mm. Now start the contour flange command, and create the Z profile in the sketch. With NX 4612, or older, with the profile command. If you are working with a newer version, use the line command. Both commands work very similarly. In contrast to a U profile, a Z profile changes its direction. The sheet thickness is here on the inside, and there, on the outside. However, the profile should look identical from both sides, so the length of this bend must be identical. The solution is quite simple. An offset curve defines the sheet thickness on the other side. The distance of the offset curve corresponds to the sheet thickness. Convert the offset curve into a reference curve, so that it is ignored for the profile. This makes it possible to give both curves the same length. After finishing the sketch, it can be seen that the profile has the same length on both sides. Don't just enter the value as the length, enter L equals 1500 instead. This way you have already created the parameter L. The mounting brackets are now added with the flange command. The command was shown in exercise SM2. Select the long outer edge and compare the settings shown here. The corner radii are still missing. Start now the whole command. Position the holes in the center of the corner radii. This saves you the effort of dimensioning the positions. The first flange is now complete and can be mirrored on the other side. Then both flanges are mirrored to the other end. That already looks really good. Normal cutout. Before we start, I would like to show you why the openings for the U profile should not be created with the extrude command. When extruding the sketch, sheet edges are created that are not perpendicular to the surface. However, such openings are punched or laser cut. Therefore, all edges on sheet metal parts are perpendicular to the surface. For this we need the normal cutout command. Create the required sketch, and then start the normal cutout command. As in the extrude command, various options are available for the depth. The value option allows the depth to be changed dynamically. The opening always creates sheet edges that are normal, in other words, perpendicular to the surface. The through all option creates the opening across the entire Z profile. This completes the opening. But to illustrate the difference once again, I will create a solid using the same sketch. The cross-section shows that this solid body only touches the edges of the opening. Pattern feature. The number of shelves depends on two parameters: the length of the Z profile and the distance between the shelves. Start the pattern feature command. Select the features and define the vector. The number is calculated automatically with the pitch and span option. The distance between the shelves should be D equals 300 mm. And the span distance is L minus 250. If you now increase the length of the Z profile, new openings are automatically created. This creates a universally customizable shelf. Create the U profile. The second part only contains commands that you have already learnt. I will therefore only give you a brief summary. The sheet thickness has now been set to 3 mm in the default settings. The U profile is created using the contour flange command. Then comes the U-shaped opening on this side. And the tab can now be created with the bend command. Just break the edges, and the part is finished. And finally, everything is assembled. Assemble the complete shelf. The wooden shelf is simply a block and all edges have chamfers. Only the surface has been changed, so that it looks like wood. You can find out more about this topic in this video. A parent assembly is now created. Firstly, the shelf is fixed. And then the U profiles are positioned at the four corners. To display the gray plate as a wooden board again, the studio display must also be activated in this assembly. This can be done by holding down the middle mouse button, or using the shortcut Shift and T. Once again, a parent assembly has been created. Now, the first shelf beam is added. Its position is fixed. The U profile should now be aligned with the bottom hole. The component can be roughly aligned using Move Component. The U profile is smaller than the hole in the support. With the center option, two surfaces of the U profile can be aligned centrally with two surfaces of the hole. The touch option is used for the two remaining alignments. Important. This aligns the U profile to a copied surface. The parameters of the copies can therefore also be used to copy the shelves. Start the pattern component command and select the reference option. And all the shelves are inserted. If the length of the Z profiles changes, the number of shelves is automatically adjusted. A short test. I activate the Z profile and change the length to 2500. More openings are automatically created, and more shelves are inserted. Together with the Z profile on the other corner, the shelving element is now complete. A parent assembly is created again, and the first shelf element is fixed. The element can now be copied with pattern component. But this time, with the layout linear and the option count and pitch. And a complete high bay warehouse is ready. Not yet perfect for storing parcels, but perfect for explaining the commands. And the overall height, as well as the height of the compartments, can be easily adjusted. The next video is also about the contour flange command, which offers even more helpful options. Well, that's it for now. If you have any questions or requests, please write in the comments, or send me an email directly to info@learnnx.com.